Okay, I'm going to show you how to do a simple linear programming maximization problem on Excel. This is, no, if those of you that are taking my class, this is problem number 10 in your textbook, this one right here. I'm going to go ahead and let you pause the video and type everything I have in here. And then once you've done that, start the video up again. Okay, so pause the video right now. Okay, so now you should be back. I'm going to go ahead and move this problem over. It should be kind of, you should be able to kind of see how I set it up, where I have the variable a and b. The objective function has the constant 2 and 3 in front of it. The constraint functions are right here. A and b is greater than 0, that's right here. So all the information given in the problem is given right here. So I'm going to move this out of the way. And first thing you want to do is you have to find the intercepts, because in order to find the optimal solution using graphing, you have to find the intercepts. So I'm going to say if a is 0 in this first equivalent constraint, let me copy this down. So for constraint 1, if a is 0, what does b have to be? Well, it has to be equal to 6 divided by 2. Because 2 times 3 is 6, right? And if b is 0, well, this has to be equal to this divided by this. Okay. Now I may be going a little bit fast, but the reason I'm going fast is because there's no reason for me to go slow, because if you miss something, you can pause it or rewind or whatever you need to do. So that way, for those of you that are keeping up, you don't have, I'm not going too slow for it. So now I'm going to go equals this divided by this, right, for this one. And this one I'm going to go equals this divided by this. So now I have my intercepts. So now it's just a simple matter of graphing it. And I'm going to move this, I think I'm going to move this up here for now. Okay, so I'm going to go ahead and create a graph. So let me go ahead and copy this down so we know that this is constraint 2. So I'm going to create a graph. So I've done this in other videos also, so that's another reason I'm going kind of fast. So I'm going to highlight this. I'm going to go insert, scatter, XY, switch row and column. Okay. And then I'm going to go to layout, and I'm going to go to axis titles, primary horizontal title below. Here I'm going to go equals A, and then I'm going to go axis titles, primary axis title, vertical rotated, and then here I'm going to go equals B. So I've got a label so I can see where things are. And this is 6, 0, that's 6, 0, this is 0, 3, that's 0, 3, that all looks correct. So I need to add some data. So I'm going to go to Design, select Data, Add, Series Name. If I want to, I could put a series name because I call it constraint 2, right? And then here, the X values are here. The Y values, I'm going to hit the backspace a few times, and then I'm going to select these and go OK. Now also, I can also go edit. I can go to this one and go edit. I can add the constraint name on that one. All right, go OK. Okay. So now I have so now I know constraint 2 is this one and constraint 1 is this one. So now I have my feasible region. Now I can figure out my feasible region. So this constraint just means it's the first quadrant because A is greater than 0. So this is A. Everything to the right of this line is going to be, everything in this direction from this line is going to be shaded. Okay. And then B is greater than 0. Everything from this horizontal line up is going to be shaded. Okay. So basically, my solution, the lower bound of my feasible region is going to be right here. This line and this line. Okay. And now this is shaded to the left. So constraint 1 is the blue one. So it'd be this one. It's shaded to the left because if you have a less than or equal, you always want to remember it's shaded below and to the left, right? So my triangle, for this constraint, my triangle, since it's bounded on the bottom right here, and you have to shade from this line to the left according to this arrow right here. My triangle would be, you could use the color light gray and shade this little triangle here bounded by 0, 0, 0, 3, and 6, 0. Okay. For the second constraint, the red one, it also is shaded to the left. So I'd go from this line and shade it in this direction, and I'm bounded right here. So this bound for this one would be 0, 0, 0, 5, and 3, 0. So I have two triangles, you could call them shaded light gray. Right here would be where it'd be shaded the darker gray, right? So it'd be 4 points. So we can see that this is 0, 0, this is 0, 3, and this is 3, 3, 0. Okay, so so this point, and 0, 0 are, but we don't know this point. So what we're going to do is we're going to figure out how to find that point. So what I'm going to do is I'm going to go A and B, and in Unit 1, I have an area that shows you how to do Cramer's rule. We're going to do that algebraically. But in this case, I'm just going to do it a little bit quicker way. So just kind of watch how I do this, and this will help you maybe later on. So I'm going to highlight this. You know what I could do? Let me move this down. And we're going to take all these. You know what I'll do? I'll go equals this, and I'll copy it over. And I'll copy it down. That way we have it down here again. Okay, so what I'm going to do is I'm going to highlight these, and I'm going to go equals, matrix multiply, parentheses, matrix inverse, parentheses. I'm going to highlight this, and then close the parentheses, and then close the parentheses, and then comma, and then this, and then close the parentheses. Now this is where it's different. You've probably never seen this in Excel. I'm going to hold down Control and Shift on the lower left-hand corner of the keyboard, and then I'm going to hit the Enter key. It's going to give me my answers. Okay. So those are my two answers. This is at like approximately 1.74 and approximately 2.14. So that's that corner point. So now I can put in my corner points. And I'm going to say points that bound the...
I thought I heard you down here.
Okay, sorry about that. I had to pause the video for a second. Points that bound the feasible region. Okay. All right, so I can list them here. It's equal to this one, and it's equal to that one. All right. And I guess we can go in here, insert, and go A and B, and then this one is equal to 0. Oh, equals to 0. I can drag it across to get the 3. And this one is the 3. I can drag that across to get the 0 coordinate. And the other one is 0. I'm going to type it in 0, 0. Okay, so those are these are my points that bound my feasible region. Okay, so now we want to find the z. So we know 0 times 0, or 0 times 1 plus 0 times 2 is 0. So this answer is going to be 0. And we can calculate these out. 0 times 2 plus 0 times 3 is 9, so the answer should be 9. But I'm going to use, again, I'm going to go ahead and use, matrix multiplication in order to figure this out. So what I'm going to do is I'm going to say it's equal to matrix multiply, and we're going to take these, and we're going to take these times the transpose of our objective function. Okay, so we're going to take a 4 by 2, and I'm going to transpose this, so I'm going to flip it vertically times a 2 by 1, which will give me a 4 by 1. Okay, and then what I'm going to do is I'm going to go Control Shift Enter. It gives me my answers. So the ones that give my maximum value are right here, okay, because we're trying to maximize it, right? So A of 1.74 and B of 2.142 gives me a maximum value of 9.857. All right, so that's one way to do it. So that's called the graphical method. And I can do it in an alternate way. Okay, and let me make this bold and underlined. What I could do is I could set this problem up. I can take, I'm going to take these right here. I go copy, and I'm going to put them here. And I'm going to copy this down. I guess let's copy it right here. And I'm going to just guess these are like 1 and 1. We don't know what they are right now. Okay. And this is all about setting it up properly. So you just set it up the way I set it up, and then you'll get it to work. So now I'm going to go, this equals matrix multiply. And let me think for a second. Got to remember how to do this. I have an example here, so I don't do it wrong for you. You go matrix multiply. So I want to take. Let me do this again. So you matrix multiply. So I'm going to take. These, okay, the original matrix up here, and you're going to take that times the transpose of these two here. Okay, and then I close the parentheses. I'm going to hold down Control Shift Enter. Now it gives me, so does that make sense? 1 times 2 plus 1 times 3 should be 5, and that's the answer. So it looks like it worked. Okay, so now we're going to do something called solver. So I'm going to go to data, and I'm going to go to the solver. If you don't have the solver here, sometimes it's not installed in Excel. You have to go to File, go to Options, and then Add-ins. Down here on Excel Add-ins, you have to go Roll, and make sure Solver Add-in is checked right here. Make sure that's checked. You go OK, and then Solver will show up. So we're going to click on Solver, and what I'm going to do is I'm going to reset everything because this is a new. Okay, so this is what you should have. You should have a blank one, and we want to set the objective. Okay, so we want to maximize this. So I want Z to be a maximum. So you're going to click on maximum. And I want to change these two. I want to change my variables A and B. And I'm going to add some constraints. I'm going to go add. I'm going to say this is less than or equal to 6, right? Because it's less than or equal to 6. I'm going to go add. And I'm going to go back down here. I'm going to say this. And go back up to the top. The less than or equal to, that's correct, right? And we're going to go 15. And then we're going to go OK this time, not add. And then you're going to say this is non-negative, and that basically makes sure that constraint is in effect. And then you want to make sure you use simplex. This is not by default going to be simplex. You're going to change it to simplex. And then you go solve. Okay, let me see what's going on. For some reason this objective moved on me. It should be pointed to this, right? I don't know why that moved. And I need to point to the Z. So this has to be here. That's what I want to set. And I got 2 of them there. So I want this to be set to that. Okay? I want to maximize it. I want to change these 2 variables. Okay? And if I go solve, you'll see that this changed all of a sudden, right? It's got the answer. So I'm going to say keep the solution. I'm going to go OK. So that's the answer. And this is a Z. And that's exactly the same as what we had up here. Okay, so that's an alternate solution where you wouldn't have to go through all this, finding the intercepts and everything. You just set it up this way, real short, and we'll find it. Another thing, so what point is it? It's this point right here. Okay, because that's these 2 points, right? So it's this point. That's what we found out. And then this point, plugging these numbers into, so 1.714 times 1 plus 2.14 times 2 is going to give you a value of 9.85, which is the maximum. So you could say this is maximizing profit. You don't know what you're maximizing, but it's going to maximize whatever you want to do. So that's it for that problem. Thank you.